Hello, I'm Riker Flam, and this is acid deposition.
There are two main types of acid deposition, wet and dry deposition. Pollutants mix with the water in the atmosphere, acidify the water, and fall down as precipitation in wet acid deposition, commonly known as acid rain. Many people forget that there is a second type of acid deposition, known as dry acid deposition, where pollutants mix with solids in the atmosphere or remain gases and fall back down as a solid or gas. This causes structural or botanical damage and is mainly caused by acidic compounds. These acidic compounds that lead to acid deposition are nitrogen oxides, sulfur oxides, and carbon oxides. Concerning acid deposition, nitrogen oxides and sulfur oxides are the two main culprits. Carbon oxides technically can cause acid deposition, but the acid it forms, carbonic acid, is generally too weak to cause any real damage, and most rain already has a bit of carbonic acid in it. It's just hard to notice because of how weak carbonic acid is. To demonstrate the process, here we have an anthropogenic or man-made source of the compounds that lead to acid deposition, a power plant. This particular power plant burns coal, but almost any power plant that burns any form of fossil fuels can lead to acid deposition. Since this one burns coal, it releases nitrogen oxides in the form of nitrates and sulfur oxides in the form of sulfur dioxide. These primary pollutants exit the power plant and head towards the atmosphere. Not all sources of acid depositions are man-made. Here we have a non-anthropogenic source of sulfur dioxide, a volcano. These are found in nature commonly and do release sulfur when they erupt. Nitrate is also commonly found in nature. It is released every single time there is a lightning strike. While these sources are found in nature, they pale in comparison to the amount of pollutants humans release. Once released, these primary pollutants head into the atmosphere, or more specifically the troposphere, the lowest level of the atmosphere, where weather happens. Once high enough, in the case of wet acid deposition, they mix with water in the atmosphere to form a wet acid to fall down as acid rain. In nitrate's case, it forms nitric acid. Once it is nitric acid, a secondary pollutant, it falls back to the ground as acid precipitation. In the case of dry acid deposition, as demonstrated by sulfur dioxide, the pollutant comes up to the troposphere, as does wet acid deposition, but in many cases it remains a gas and does not even mix with anything. Since it goes back to the ground in a state other than liquid, it is dry acid deposition. In many cases, sulfur is turned into a salt where it falls down, and that's still dry acid deposition, but in this case it's a gas. The acidic compound deposits back on the ground, in this case an urban area, where it has many consequences, which we will explain in the next slide. But for now, just know the nitric acid falls down as a liquid and the sulfur comes down as a gas. The main human consequence of acid deposition is that any statue that's very detailed or any structure with low acid deposition can be permanently ruined due to the acidity of the compounds coming down. But the environmental impact is much more drastic. Plants, animals, and especially aquatic life can be impacted through affecting water pH, which many aquatic species need a pH of 4.8 to survive, and many fish eggs can't even hatch with acidic water. This reduces biodiversity too, as there's less species that are able to hatch. Some solutions to acid deposition are liming, which is where powdered limestone can be added to smaller bodies of water in order to neutralize the acidity caused by acid deposition. It's not too effective as it's only able to be used in bodies of water that are small enough, and it only affects aquatic species, still not helping with the human impact and plant life and animals. It's also very expensive as liming is a temporary solution to a permanent problem. In order to help this permanent problem, some prevention methods are using cleaner sources of energy, such as wind or solar, instead of burning fossil fuels, which is what releases these chemicals and compounds, or making renewable sources of energy more accessible and affordable to the public. A more active solution would be encouraging coal plants to wash the coal that they burn in order to lower sulfur emissions. Coal can be washed through density separation, which is where coal is added to water and the particles sink or float depending on density in order to remove the sulfur.